Welcome to today's Explainer. If you build software for a living, there is absolutely no way you miss the headlines about Google's latest AI drop. But look, today we are skipping all that shiny marketing fluff and diving straight into the actual data. We're going to evaluate Gemini 3.5 Flash specifically for your professional coding workflows to figure out if it really deserves a spot in your daily toolkit.
Let's kick things off with Google's biggest, boldest claim. They're promising frontier performance at 4 times the speed, often at less than half the cost. I mean, on paper, the stats backing this up are wild. A 1 million token context window, 64,000 output tokens, and native multimodal inputs across text, images, video, audio, and PDFs. It sounds like the absolute silver bullet developers have been waiting for. But that brings us to the core question of our explainer today. Does Gemini 3.5 Flash actually belong in your tech stack? We're going to figure that out by cutting right through the noise, looking at real-world benchmarks, the true operational costs, and the actual code it spits out. Because, let's be real, what a model does in a pristine lab environment versus what it does in your IDE, yeah, those can be two entirely different things.
So here is our roadmap for the day. First, the benchmark reality check. Second, speed versus token costs. Third, evaluating UI generation quality. Fourth, the anti-gravity ecosystem shift. And finally, the final verdict for developers.
Starting right in with Section 1, the benchmark reality check, unpacking the data.
Now, Google's own internal coding benchmarks are, well, incredibly optimistic. According to their data, Gemini 3.5 Flash is practically tied with GPT 5.5 for coding tasks, trailing just a few percentage points on SWB Pro. And get this, they claim it actually beats Claude Opus 4.7 on Terminal Bench by roughly 10%. If you take that at face value, it looks like Google just delivered a super lightweight model that completely punches above its weight class for software engineering tasks.
But, hold on a second. When we look at independent testing from artificial analysis, it's a totally different story. On their coding index, Flash scores a 45. That puts it solidly behind both Kimi K 2.6 and Claude Opus. Honestly, it doesn't even beat Google's older Gemini 3.1 Pro model. The big takeaway here? While its agentic performance, meaning its ability to handle multi-step tool use, got a nice bump, its raw coding logic just does not match the frontier models like Google's internal tests suggested.
Which leads us to Section 2, speed versus token costs, the ultimate trade-off. Okay, if there is one absolute, undeniable triumph for this model, it's the speed. It processes 288 tokens per second. That is literally blistering. It completely smokes Opus 4.7, GPT 5.5, and even highly optimized open-source models. If you're building an application that relies on lightning-fast, multimodal processing where latency is your biggest enemy, Gemini 3.5 Flash is arguably the best tool in the business right now.
But wow, the trade-off is staggering. $1,552. That is the actual cost artificial analysis racked up running their intelligence index with this model. See, on paper, Flash costs just $1.50 per million input tokens, which sounds incredibly cheap, right? But in the real world, running that benchmark made it 5.5 times more expensive than Gemini 3 Flash and 75% pricier than Gemini 3.1 Pro.
So why does the bill get so out of control? It turns out Gemini 3.5 Flash is incredibly token hungry. When put through agentic evaluations, it averaged 49 turns per task. It just completely chews through your input context window. The reality is, yes, it generates tokens super fast, but its inefficient reasoning means it needs dozens of back-and-forth loops just to solve a problem. Ultimately, that makes it way more expensive to run for complex coding tasks than if you just used a high-reasoning model like GPT 5.5 right from the start.
Moving on to Section 3, evaluating UI generation quality, our front-end showdown.
The source data gives us a really great test case here, building a full-stack personal finance dashboard. And the workflow differences? It's night and day. Flash was wildly fast, spitting out a functional web app in literally 5 minutes. But the output was a very predictable AI-looking design, using those generic gradients we've all seen a million times, and it weirdly named the app Aura Wealth. Opus 4.7, on the other hand, took a full 20 minutes, so 4 times as long. But it handed back a highly professional, production-ready UI that needed almost 0 edits. For professional web projects, raw speed rarely outweighs the need for high-quality, deployable code. Let's jump to Section 4, the anti-gravity ecosystem shift, changing up the tools.
Beyond just the model, Google dropped anti-gravity too. It's no longer just an IDE extension, it's a full-blown standalone app, but the second you open it, you're going to notice it borrows heavily from tools that are already out there. If you've spent any time in Codex or Cursor, the layout is basically identical. You've got your conversations on the left, your projects and scheduled tasks, and the standard diff view for your files. So while it's highly capable, it feels a little less like a massive leap forward, and a bit more like Google playing catch-up to what developers are already using every day.
And for those of you who practically live in the terminal, this next part is huge. Google is shutting down the Gemini CLI on June 18th and swapping it entirely for the new anti-gravity CLI. Under the hood, it's been completely rewritten in Go. But the real kicker, the part causing the most friction for the software engineering community, is that it's now 100% closed source. This is a fundamental shift in how developers interact with Google's AI locally, totally stripping away the community-driven transparency that a lot of us really relied on.
Which brings us to our final section, the final verdict. For developers, the bottom line. To wrap all of this up, this explainer paints a picture of a really mixed bag if you're looking for a new daily driver. On one hand, you are getting unbelievable raw speed and pretty decent multi-step agent capabilities. On the other hand, it's prohibitively expensive because it burns through tokens with those inefficient 49-turn reasoning loops we talked about. At the end of the day, its foundational coding logic just trails too far behind the true frontier models. For serious production environments, the speed benefits simply do not outweigh the coding limitations. Right now, the best move for professional developers is probably to hold off and wait for Gemini 3.5 Pro.
But I want to leave you with one final provocative thought. Google built an AI model that is blazingly fast at multimodal tasks, but surprisingly weak and weirdly expensive when it comes to deep coding logic. Plus, they just locked down their CLI source code. So you really have to ask yourself, if dedicated software engineers aren't Google's main focus for this release, who exactly is? Maybe their true target here is just the everyday consumer, using it to power background tasks in Gmail, Workspace, and Android, rather than helping you write your next production backend. Just something to chew on the next time you're picking a model for your stack. Thanks so much for tuning in to today's explainer, and keep building.